All right. I don't know if you ever feel like, man, I took notes, I watched your video, and then I start working on the homework and I'm like, what? Okay, so let's look at what we got going on. We got a pair of triangles that are similar. All right, now let's look back at our notes for a second. In our notes, we had the pair of triangles discussion going on up here. And what we said is if there's a scale factor that you can figure out, any corresponding part is going to be in that same scale factor. The altitudes are going to be in that scale factor. The perimeters are going to be in that scale factor. The areas are a different story because area is, one dimension times another. We're not talking about area right now. We're talking about lengths in a ratio, right? So when I look at problem number one, I see that they're telling me that I got a pair of triangles that are similar, right? So this is the first part of our notes. When we try the next problem, we're going to skip to problem 8 and try that together. We only have one triangle here. You might say, no, we got a triangle over here and a triangle over here, but they're not saying that these two triangles are similar to each other. They're not similar to each other. We just have one triangle with the angle bisector, okay? So when we look back at our notes, look at the notes where we have just one triangle with the angle bisector. I'm not trying to insult your intelligence, but we're trying to make use of our notes, and sometimes I think people copy notes down because the teacher tells them to, and then they're not exactly sure how to apply their notes, So we're trying to go back and look and say, oh yeah, this is the drawing that applies to that problem that we're going to do on problem 8, and this is the drawing that applies on problem number 1. Okay, so how do we do the problem? Well, I mean, you could, if this makes more sense, you could take this whole side and say, okay, this whole side's 14, and this whole side is, what is that, 10.5, right? So this is 10.5, and then we could match up a ratio. So if they're similar to each other and they don't tell us which one the image is and which one's the pre-image, it doesn't really matter how you do this, but I guess I'll take the bigger number divided by the smaller number. Okay, that's my scale factor. Even though it's not maybe a proper fraction, you're not supposed to have decimals in the fraction. Somebody would say, hey, you're supposed to get rid of that decimal and reduce the fraction down. It's probably a good point, but I'm not going to do it because it doesn't really matter. You could have taken 5.25 over 7. That would have worked too, right? Now, this is kind of an odd problem in that, this is going perpendicular, right? So it's a perpendicular bisector because it's, going to the midpoint over here. It's also the altitude. It is, let's see, what else is it? It's also an angle bisector because we've got an isosceles triangle. So anyways, we don't need to worry about any of that. But these are corresponding parts too, right? Now I did put 14 over 10.5, so I'm going to have to go 22 over x. If you go x over 22, that's not going to work for you, right? You want the bigger triangle in the numerator and the smaller triangles parts in the denominator. Why? Because I decided to go 14 over 10.5. If you went 10.5 over 14, then you'd have it the other way over here. Now, I would like to get this 10.5 out of the denominator. It's dividing into 14. So how do I undo divide by 10.5? I multiply both sides by 10.5. And so now I've got the 10.5, dividing into here. So now I've got 14 is equal to 22 times 10.5. And maybe parentheses would be better because I got dots all over the place if I don't. Okay, so I'm multiplying those two together, and I'm dividing by x, right? And then I'm going to multiply this side by x, and I'm going to multiply this side by x. And usually we put the x after the constant. So there's my coefficient. That's what that's called. And then the x's over here divide out, and we get whatever 22 times 10.5 is. Okay. Now we're going to divide both sides by 14. Whew, it's a lot of work, isn't it? See, I'm showing you every step here, and I'm not saying cross multiply, just in case somebody's still a little uneasy that really what happens is the 10.5 times 22 and the x times the 14. That's really what happens because we're multiplying both sides by the denominators. But anyways, it's time for us to jump over to Desmos, right? So let's get our computer over to Desmos. I haven't been using that. I've been using GeoGebra, right? And I needed to do, what was it, 20? It was 22 times 10.5 divided by 14. And I've been trying to convince people that, you know, sometimes like if you break this off over here as a separate tab, now you can go Alt Tab to switch between different windows, right? So I'd kind of like my Desmos on top of this window. So if I do Alt Tab one more time, I've got Desmos in one window and I've got my work over here. And I know you guys don't have this little app over here, but quite often I see you guys want two windows. You could also like push it over here until it does that little highlight thing. It says, hey, do you want that tile on this side? Did you see that? And then I choose what I want on my right side. Unfortunately, like this isn't necessarily better right now because I can't see my work, but I can scroll it over here. All right, here we go. Now I go 22 times, that's Shift 8, 10.5. I think this is fewer keystrokes than putting the parentheses in. Then divided by 14. Now you might say, oh geez, Nelson, the 14 is not under the 22. It's okay. You can divide the 14 into the 10.5, then multiply that by 22. Desmos is doing the right thing here for us. So we got 16.5. Okay, that's my answer for problem number 1. I gotta find my pen here. So 16.5. I hope I'm making that clear. Let's just kind of review it one more time. You have two triangles that are similar to each other. You have these altitudes or angle bisectors or perpendicular bisectors. They're all three of them. Medians, it's also the median. They're in the same ratio as the scale factor. That's what we said in our notes. That was the first bit of notes that we took. Now, the second problem that I want to do with you is number 8, and this one's a little crazier because we have just one triangle. And like I said in the proof, it involves similar triangles. You have to draw in another auxiliary line and extend this line out where they intersect, and then you get a couple similar triangles. I'm not going to do that, okay? Not going to do that proof. So here's what happens. You just take like 12 over 26, and you set it equal to 8 over m. And then we solve. Now, I have said a number of times that proportions are flexible. So what I mean by that is we could take the reciprocal of this side. Okay, let me see if I can, I'm going to put it on the other side. M over 8. Do you see that? I took the reciprocal of this right side of the equation, but then I would take the reciprocal of the left side. So I'm going to put 26 over 12. Now, what's the benefit of doing this? Well, all I really need to do is undo this divide by 8, and I'd have m all by itself. So there's one multiplication that I need to do. Somebody might say, you know, you probably should reduce the left side. Well, I'm going to use Desmos anyway, so I really don't honestly care that this isn't reduced over here, because what I'm going to do is I'm going to go 26 times 8 divided by 12, and I'm done like that. M is 17 1/3. So let's come over here and put m equals 17.3 repeating. It does say round to the nearest tenth, so I'd get rid of the little bar and say it's approximately equal to. Okay, so let me erase the little bar over the top. All right. If you need a little bit more convincing that all I need to do is one step of arithmetic here, let me show you. See, I'm going to multiply both sides by 8. 8's divided out here. Then I got to multiply this side by 8. And that's what I did on Desmos, isn't it? Didn't I take 26 times 8 divided by 12? Okay. Now, if it's still like messing with you a little bit, like what? You can't do that, Nelson. You need to have the 26 up here. Go ahead and put it up there and see if we get the same number, right? See, we get 17.3 something. So, hey, thanks for watching my video today. I really appreciate it. I hope you're doing okay. I'll walk around and I'll help you out.